Hello everyone, I'm Tanu Rajput and here I am doing internship at Spark Foundation. So I came here with my first task prediction using supervised machine learning. The level of the task is beginner. So what is the main purpose of the task is to predict the percentage of an student based on the number of study hours. So basically we have to use simple linear regression in the task as it involves only two variables. First one is hours and the second one is scores. So here we have many options. We can use R, Python, SAS, or whatever tool we want to use to predict the scores. Okay. So here let's come to the data set first. Let's take a look on the data set. Here we have two variables. First one is hours and the second one is scores. Now come to the task. So I am from 2023 batch of January in GRIP. So let's start with the prediction using supervised machine learning, our first task. So as we discussed before, our objective is to train the machine learning model and to predict the percentage of the students based on the number of studies hours. So let's get started. Here, firstly, what we have to do, we have to mount the Google Drive into the Google Colab so that we can extract or we can use our data set for the further process. So for that, firstly, I have imported the Google Drive into the Colab. For that, I use this code, and after importing, I just import a few libraries which I will use in my visualization and in cleaning and in machine learning modeling. So here I have import numpy as np, import pandas as pd, import matplotlib .pyplot as plt, and import cbone as sns, import sklearn.model, selection import train test split to split the data set into two parts. Like first one is testing data set and second one is or training data set. And the last I import from sklearn.matrix, import mean square error, r2 square and mean absolute error. So here I also have write a code for ignore warnings. Now let's start with loading the data set. Here we use the panda library and pd.read.csv, as we have the file in csv format, so we use pd.read.csv and we just import load our data set, and here we just pick the first 5 rows which we have 2.5 hours as 21 scores. To if we have 5 student study 5.1 hours, then he will score 47. Means we here let's also see the shape of the data set. We have total of 25 rows and 2 columns, and information of the data set. In information we will see that either we have null or we have not null, or we will check the data type. As here we can see that in ours column we have no null values and the data type of our column is float. But in scores column again we also do not have no null values, and the data type of scores is integer data type. So after checking the information of data set, let's check the duplicate value in the data set. But here we can clearly see that we do not have any duplicate in the data set. So let's move to let's check again null values in a simpler way by using df.isAny.sum. Here we can get the count of null values if we have, but here we have no null values, so we have count 0 for both the variables. Now let's see the statistical description of the features we have. So for our column we can see that total count of rows we have 25 and the mean of the hours is 5.012, means it means that that average hours studies by a student is 5 hours, and here we can see that we have minimum 1 hour, we have maximum 9.2 hours, and in the case of scores we have average of 51 scores, near about 51 scores, and we have minimum 17 scores and maximum 95 scores. So now come to the correlation. Let's check the correlation in the given data set. Here we can see that hours and scores are highly correlated to each other, because we have correlation of hours to scores is 0.97 and the scores to R is again 0.97. So it indicates that both are highly correlated. So now let's move ahead with our data visualization. So here we will explore the data visually. Firstly, again, I have drawn the correlation matrix. Here we can clearly see that scores and R's are highly correlated, as they have 0.98. So now, checking the relation between hours and percentage via scatter plot with histogram. I have drawn a plot with a combination of scatter plot and a histogram. Here I have compared hours with scores. So we can clearly see that there is a linear relationship. We have a positive linear relationship in both the columns. So we don't need, and we can use linear regression, because in linear regression our one merit is that we have a linear correlation between the independent and dependent variables. So here we have, so we can use linear regression for this. Now let's check the distribution for both the column, and as we know, first point is that our output variable here is scores, but we have drawn for both the columns distribution to see the distribution for both, and here we can clearly see that we have almost a normalized distribution. So we don't need to apply transformation on any one of them or any of them, and especially on the score column, because that is our target column. So let's start our modeling part. For modeling, firstly, I have to tell you that why we are modeling here. We are modeling here to predict the scores for an X number of hours a student study. Okay, so here we will use linear regression, as we have two variables and a linear relationship between both the variables. So I'll using linear regression to predict and to train the model. So let's prepare data for modeling. Okay, so firstly, our first task is to split the data set into X and Y, means independent and dependent variable. So our dependent variable here is scores, and our independent variable here is other than score, which is R. So here X is goes to R column and Y is goes to scores column. So now if we want to see the shape of both the data set, so we can see that X dot shape, we have 25 rows and one column, as it is R's column, and for Y dot shape again we have 25 rows. So after dividing the data in independent and dependent variable, we have to split the data. So to split the data, we have a library from sklearn.model selection import train test split. We use train test split to split the data set into training and testing data set. So here we can see that we have X train, X text, Y train, Y test. So we are splitting our data set into four forms. First one is X train, X test, and then Y train, Y test, because we have to train and test. Firstly, we have to train the model with the help of this training data set, and then we will test the model with the help of the testing data set. So here we can see the shape of all the data sets after splitting. Now we'll start our training of models. So here, firstly we'll import the library from sklearn.linear model, import linear regression, and after importing the library, we will fit the data, we will fit the model, sorry, we will fit the model, and we will fit the model with the help of xtrain and with the help of ytrain. After fitting the data set, then we will transform the data. But before transforming, we will see that here we have coefficient. We get the coefficient 9.61405732, and we get the intercept 3.37 something. So we can clearly see that we have a good training, which means that model fits so well. So let's move ahead, and it's time to predict the value, which is our objective of the project. So let's predict the value for the test data. We have as we split the data into test and training, so it's time to test that model on that testing data set. So here, as we predict on testing data set, we get these scores. Now, let's calculate the matrix. Okay, firstly we'll calculate mean absolute percentage error. So for that I used mean squared error, and I gave the parameters y test and the predicted value. Okay, so I have calculated R2 score, adjusted R2 and MSE, and here what we get, R2 score as 0.91 something something, and adjusted R2 score as 0.90 something something, and MSE as 28.38 something. So let's see the difference between actual and predicted scores. So here we have our actual values, and we have also the values which we have predicted. So for number of R7, we have actual value, sorry, 60, but predicted value is 56, which is almost nearest to 60. And the same as for 85, we have predicted 77. For 76, we have predicted 69, and for 81, we have predicted 83. So actual values and prediction values are almost, not exactly or not nearly. It's almost near to each other, but we need a good perfection, like but it's okay with it, as we have a linear relationship between both the waves, so we can use only linear regression, and we can also get a good prediction by applying this. So it's time to predict the value, or I mean to say the score, when the student studies for 9.25 hours. So here we have predicted for hours 9.25. So when I predict it, then I get the score 92.300 something. So according to the regression model, if a student studies for 9.25 hours a day, probably the percentage of score is 92.30. So it's all about the prediction by using linear regression model. So thank you.